Okay, good morning, Transitional Algebra 2. Mr. Prashar here. I hope you're enjoying your day so far. Looking out the window, the sun's out finally. That's a pleasant surprise. If you have some time today, get outside for a little bit, get some sun. I know I have to go cut my grass and do stuff like that. Today's topic is one that just got released on your assignment due next week on Monday. But this is a topic that's very important in mathematics, something that's been around for a very long time, very long time. And it's something some of you may have done last year with me, if you have me, for Algebra 2 or Transitional Algebra 1, which is the quadratic formula. So I'll write that up here. So the quadratic formula is this formula right here. X equals negative b plus or minus b squared minus 4ac underneath that square root all over 2a. Now, where the heck does that come from? I'll show you at the end of the video where that comes from. How long has this been around? Long time. First use of this goes back actually to the 9th century, present-day Iraq. At that time it was Babylon. But it was thought to be used then, but it really wasn't until the late 1500s, early 1600s when this got finally established, a proof was given, and we were able to know for sure 100% that what we're doing here is correct and just not some kind of made-up crap that mathematicians have been using before that. Other mathematicians that get credit for this, a mathematician named Stevin. Stevin was actually the man that came up with the notation for the equal sign. And our famous friend Rene Descartes, the coordinate plane guy, he actually takes credit too to some form with this quadratic formula. Now, when do we use the quadratic formula? Well, we use it when we want to solve equations that have this form. ax squared plus bx plus c equals 0. So whenever we have an equation that takes this form, ax squared plus bx plus c equals 0, where a is some kind of real constant, b is a real constant, c is a real constant, and actually we can extend it into the complex, but that's another story. So whenever we have an equation that's written in this form, you have the green light to go ahead and use the quadratic formula. And it's kind of funny mathematically because students will always like to go back to the quadratic formula even if you're able to factor something, but nobody likes to factor, right? You guys especially, right? Some of you hate to factor, I know that for a fact. So the quadratic formula always will work. It'll get you out of any kind of jam. So we're going to look at examples today where we can't necessarily factor and we have to use this formula. Okay? So one of the things that we have to keep in mind is if we have a quadratic equation, which is this guy here, and it's not written like this, we may have to rearrange it. And we'll see that in some examples. So let's get right to it. We'll leave the formula there. So look at a problem like this. We have 3x squared plus 11x minus 4 equals 0. Okay, so let's go ahead and take care of this. We want to solve this, and perhaps we can't factor it, right? And if you don't like the factor, you're going to skip the factoring and go right to the quadratic formula. We need some things here. We need an a, b, and a c. So the number that's attached to the x squared is always your a. The number that's attached to the x is always your b. And the constant number is your c. And it's important to note that you always take the sign with it as well. So if it's positive, it's a positive. If it's negative, like this case, you have c is negative 4, that minus sign always goes with it. That's probably one of the leading mistakes students will make is they don't put the sign with it. So now with that being said, we could go ahead and fill the formula in. So here's the formula. X equals negative b plus or minus. So plus or minus means that you're going to get two answers to this problem in the end. Under the square root b squared minus 4ac, which by the way, this thing holds a special property, this b squared minus 4ac. Down the road you'll learn something called the discriminant. And the whole thing is divided by 2a, the whole thing. So we have x equals negative 11 plus or minus b squared, so that's going to be 11 squared, minus 4 times a, which is 3, times c, which is negative 4. All divided by 2 times 3, because remember 3 stands for a. So that's the initial part, is the setup, plugging into the formula, okay? So now we're just going to carefully go ahead and simplify. You have negative 11 plus or minus 11 squared, right? How much is 11 squared? That's 11 times 11. I think we got 121. Now we have negative, you got to do the order of operations. So you got negative 4 times 3, which is negative 12, and negative 12 times a negative 4 would be a positive 48. And this whole thing is divided by 6, because 2 times 3 is 6. So again, this is just basic operations. I'm giving you a heads up. Don't try to jam all this in your calculator. You're very tempted to do that, but it's very wise if you actually write out all the steps like I'm doing, because then it makes using the calculator easier at the end. So x equals negative 11 plus or minus the square root of, we have 121 and 48. That gives you 169 divided by 6. And what you're going to see here is this is really nice. This doesn't happen all the time, people, but you know, the square root of 169 is actually 13. So that leaves us with x equals negative 11 plus or minus 13 over 6. So you see how we have this plus or minus. We need to rewrite this thing 2 times. So one way we're going to write this is x equals negative 11 plus 13 over 6, or x equals negative 11 minus 13 over 6. Either way, you got to show it. You're going to get 2 answers from it. Quadratic equations have 2 answers because of the squared, x squared. Delete terms in x squared, so you're going to have 2 answers. If you had an x cubed, you're going to have at most 3 answers. If it was an x to the 4th, you'd have at most 4 answers. So these are the tricks of the trade you pick up over time. So simplify these individually. Negative 11 plus 13, that's going to give you 2, right? So you got 2/6, and that reduces to 1/3. So that's one of your solutions. And over here, you have x equals negative 11 minus 13. That's going to be x equals negative 24/6, which will reduce to negative 4. So your solution set for this problem here is 1/3 and negative 4. That is your 2 answers. And if you would go back and plug into the original equation right here, you would see that this side here, when combined, would give you the 0 that you see on the right. So that's how you use the quadratic formula. Again, some of you have seen this before, right? So it's not a big deal, but if you haven't, it's not too bad. You're just substituting in the numbers for the corresponding letter in the formula, okay? Now, what's nice about the quadratic formula is it'll solve equations that actually will not give us a real numbered solution. At this point in time, we're so used to working with the real numbers, right? However, not every equation we solve gives us real numbers. We get imaginary numbers. And at this point, we're just going to label that as not a real solution. But before the year is up in this class, we're going to learn about the imaginary numbers and the bigger set they belong to, which is the complex numbers. Okay? So this is a great example to get started with. Now let me give you another example of something that is a little more peculiar. It's kind of interesting. So say we have an equation that looks like this. x squared plus x plus 1 equals 0. So say we got this trinomial equation. So it's quadratic. We could use the quadratic formula. We have the green light to do so. It's also in the correct order that we need. Remember, they all have to look like this. ax squared plus bx plus c equals 0. They all have to take that form in order to use the quadratic formula, okay? So, what's my a, b, and c? Well, you may say, well, I don't see any numbers. Remember, there's invisible ones in front of x's with no number. So your a is going to be 1, your b is 1, and c is 1. Isn't that nice? All ones. So put these into the formula. So you got -1 plus or minus the square root b squared, so that's 1 squared minus 4 times 1 times 1. Look at that. At least it's nice small numbers over 2 times 1. So make sure before you go forward that you plugged in the right numbers. They're all ones across the board, which is nice for us this time. Okay, so now we're going to go ahead and simplify. So you got -1 plus or minus the square root of 1 squared, which is 1, minus 4 times 1 is 4, times 1 more is 4, all over 2. -1 plus or minus. Now look what happens here. 1 minus 4, how much is that? That's easy, it's -3. Uh-oh, right? If you like real numbers, this is a problem, right? This is, you know, a sad face, not too happy. The square root of -3, if you plug that in your calculator, go ahead and try it, you'll get domain error, right? Or it'll say some kind of error. That's because, remember how square roots work. When you multiply two numbers that are the same together, that gives you the square. But there's no way, ever, that you can multiply two of the same number and get a negative out of it, because two negatives multiply to give you a positive. Impossible. Or in our case, it's two positives. When you multiply two positives, you're never going to get a negative. So if you get to this point in the problem, and you see that all you have left is a negative number underneath the root, you're going to say no real solutions. Because that answer is not real. You want to know what it is? I'll tell you what it is. X is going to be -1 plus or minus I times the square root of 3 over 2. That would be the actual answer if we were going forward. You have two solutions, both imaginary, but that'll be for another lesson. But for right now, all you're responsible to say is no real solutions, and that happens when the number that's left underneath your square root is just negative. So if it's negative, game over for right now, no real solution. Okay? So it's important to understand that fact. Now I have one more example for you, and this is an example where we have to rearrange the equation before we get started. And then I'm going to show you where the quadratic formula comes from. That might be a little bit boring to you, but since I'm a math teacher, none of this stuff is boring, except if you remember from class. Do you remember what I always used to tell you I was sick of doing? Anybody remember? I always would joke about this in class. Slope, X and Y intercepts. You get tired of doing that sissy stuff. So I'll show you something a little bit interesting here after we do the next problem. Okay, so we got this problem. We have x squared equals -2x plus 15. Okay, we want to solve that for x. The problem is it's not in the correct form. You can't use the quadratic formula when you have the equals there and numbers over here. So you got to bring everything over to the left and rewrite it. So this is going to be x squared plus 2x minus 15 equals 0. Now, once it's rearranged, now it's business as usual, and we could go ahead and solve for x using the quadratic formula. Your a is going to be 1, your b is going to be 2, and your c is negative 15. Remember, there's an invisible 1 in front of any of these things that just don't have the number visible, right? So let's go ahead, we'll plug into the formula. X equals 2, negative 2, rather. And by the way, if this was a negative 2, the formula automatically comes with a negative. That would end up just being a positive there. I hope you see that. Because it's always negative b, but every example so far, this has been a positive 2. So we have x is negative 2 plus or minus the square root of 2 squared minus 4 times 1 times a minus 15. All divided by 2 times 1. Okay? Not so bad. Not so bad. So next we have negative 2 plus or minus square root of 4. Now we have negative 4 times a negative 15. That's a positive 60 over 2. So we got negative 2 plus or minus the square root of 64 over 2. And we should like that because the square root of 64 is 8. So you got x equals negative 2 plus or minus 8 over 2. So remember, you have two situations. You're going to have x equals negative 2 plus 8 over 2. And you're going to have x equals negative 2 minus 8 over 2. The first, negative 2 plus 8 is 6. 6 over 2 is 3. And this guy here, this is negative 10 over 2, which would be negative 5. So your two solutions to this problem are negative 5 and positive 3. So it worked out nice. You see, these examples are pretty good. The radicals all have perfect squares, so it's easy to reduce. So this is probably a good place to pause the video to go back and redo these 3 problems, plus look at the lecture notes that I emailed to you as well. When I come back here, I'm going to show you where the quadratic formula actually comes from. It comes from another method that we typically don't see until Algebra 2 or pre-calc, which is called completing the square. So that might be a little hazy for you, but I'm going to show you how we derive it. See, that's how mathematics works. When you learn one thing, you use it to discover another. So to complete the square actually got mathematicians to the quadratic formula. If it wasn't for complete the square, we would never have the quadratic formula. And if we didn't have factoring, we wouldn't have complete the square. You see, it's very sequential. That's how mathematics works. So let's take a pause. I'll come back and I'll show you that stuff. Okay. Good day to have your window open, especially when you're not seeing the sun for days on end. It looks pretty nice outside. Okay, so here's where we're going to start with the form of a quadratic equation. Ax squared plus bx plus c. From this formula, we're going to derive the quadratic formula, which is kind of neat. So my first step, and again, you may not understand exactly why I'm doing this, and that's okay, but I just want you to see the procedure, how things work. So remember what our goal is. We want to show at the end x equals negative b plus or minus square root of b squared minus 4ac over 2a. So we're going to prove it. And a proof is kind of like logical chain of statements that make sense, right? So think of it as traveling like from Pennsylvania to California. Unless you're flying by an airplane, even so, even on an airplane, you may have to stop maybe at O'Hare International Airport or, change flights somewhere else, just like a proof. You just don't get from A to B. You have to go A, C, D, F, Y before you get to Z. So my first step is I'm going to divide everything by A. Because when you complete the square, you can't have a number other than 1 out in front. So when I do that, I'm going to be left with x squared plus b over a times x plus c over a equals 0. So all I did was I divided everything by a, and it looks clumsy because a's an abstraction, right? So that's why we have these a's floating around. Next, what I'm going to do is I'm going to move this c divided by a over to the other side. So we'll call this negative c over a. Now, you see this middle term, this b over a? I'm going to perform some magic or witchcraft, whatever you want to call it. I'm going to take b over a, and I'm going to divide it by 2. And again, this is because we have something called complete the square. I'm going to divide b over a divided by 2. So what that means is we have b over a times essentially 1 over 2. So that gives us b over 2a, and I'm going to square it. So we've got x squared plus b over a times x plus b over 2a squared. And guess what? I'm going to write that also on the other side as well. Because in complete the square, what we're doing is we're finding this third term that's missing. And that term has to be added properly on one side. Because if you remember in algebra, what you do to one side of the equation, you have to do to the other. So now, I'm going to use some factoring magic. This is a perfect square trinomial. That's the goal, to get a perfect square trinomial. So I'm going to write this as x plus b over 2a quantity squared equals, and over here I'm going to untangle this and call this negative c over a plus b squared over 4a squared. Because if you have b over 2a squared, that's b squared over 4a squared. And that's something you should understand at this point in algebra with the rules of exponents. So you see, we're using all kinds of old stuff to do new stuff. And that's how mathematics works. So there's a lot of old stuff mixed in here that you should know, and there's some new stuff you don't know, and that's okay. I'm going to leave the left-hand side go. X plus b over 2a quantity squared, and I'm just going to combine this as one fraction, and I'm going to call this negative c times 4a, because if we want to add these two fractions, we have to go ahead and get the common denominator. So 4a squared your denominator, that means this has to be a 4ac plus a b squared. So we added these two fractions together to give us this big fraction. Now what I'm going to do next is take the square root of both sides, because we want to get rid of this thing, right? So if we have, let's start this over. If we have this x plus b over 2a squared, and that equals this negative 4ac plus b squared over 4a squared. To get rid of this 2, I'm going to go ahead and take the square root of both sides. And when I do that, I'm just left with under the root, which is x plus b over 2a equals. Now, whenever you solve an equation with the square root, that leaves us with a plus or minus when you take the root of both sides over variables. So this is going to leave us with negative 4ac plus b squared underneath this root divided by just a 2a, because the square root of 4a squared is 2a. Okay? And then what I'm going to do next, I'm just going to go ahead and reverse this order and call this b squared minus 4ac. Keep that under the root. There's the 2a. See, it's just like magic, right? It's just algebra. I'm going to go ahead now and continue on. We're almost there where we have to be. I'm going to call this x equals negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. And guess what? These two fractions have the same denominator, so we can write it as one big fraction. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And guess what, my friends? That is how you derive the quadratic formula from the standard form of a quadratic. Pretty neat, isn't it? Probably rolling your eyes out of your head, or maybe you're lost, but I just wanted to do this to show you how we use old stuff to get to new stuff. And, you know, we had adding fractions here, taking square roots, combining fractions, exponents, all these things come into play in order to do problems. So, this is a good place to stop for today. The big goal is, can you solve the quadratic equations? And I think you're all very capable of it. If you have any questions, please feel free to ask. You know, give me a call, send an email. I hope everybody's doing well. It's a nice day. Get outside, get some sun today if you can. And I'll see you next time for another rousing edition of Transitional Algebra 2. Take care.